Hello, Miss Eisencraft here with Station 5. Okay, so here we're going to estimate mu, the mean salary of full professors. I'm assuming that means full-time professors at American colleges and universities. You obtain the salaries of a random sample of 400 full-time professors. The sample mean, I don't know what happened with the formatting here. This is the sample mean from your sample. You don't have to do anything, they found it. And this is the standard deviation from the sample. Okay, and they want a 99% confidence interval. So we are going to use this. T star might be a little bit weird because your T table doesn't go to 399 for degrees of freedom. And the reason that would be, your calculator will, is because the closer and closer you get to a bigger sample, or I should say, the larger your sample is, it gets closer and closer to the normal distribution. So T star will be like Z star. And I'll even show you how close they are. So, and both of them, I got a little bit off from the actual answer here, but we're just going to go with it. So, we're going to do, since it's mean, we're going to look here, right? This is our confidence interval. Okay. And I'm going to show you this and not go straight to the calculator test because this, I guess, is more, explains more. You could use this to check. All right, and also the answers are in point estimate plus or minus the margin of error form instead of the lower bound, upper bound, which the calculator gives. So I'm going to use this. Okay, so they already give you the sample mean. Okay, 73,220 plus or minus. Now for T star, you need degrees of freedom, which is going to be 399. That's a really large sample. Okay, and the confidence level is 99. So 100 minus 99 is 1. Half of that is a half, so 0.5, and then you're going to go 0.005 for each tail. So 0.005. So you can't use your chart. You could use inverse T on here. Can't use your chart because it doesn't go that far. I'll show you. It goes to 100. Okay. So we would go to inverse T, second vars, inverse T, and we would hit 0.005 degrees of freedom, 399. And again, it's going to give me a negative. You ignore that when you're doing critical values. 2.588. So I'll just do 2.59. So this is T star 2.59. Now, see how much that differs from just the normal distribution? So if I do want to do normal distribution, second vars, inverse norm, 0.005. Let's see what happens here. We don't need degrees of freedom. Look how close these are. So the T distribution is a little bit different, but look how close it is. Okay, so I'm just going to use this one, and it's going to be a little bit off, but it's fine. Okay, T star, so we have 2.59. That's our critical value. How many standard deviations we have to go away from the mean to capture 99%. Our standard deviation of our sample was 4,400 times the square root of 400. Okay, so because they wrote it this way, we're just going to calculate this. Okay, I'm going to do this first. 4,400 divided by square root of 400. 220 times that by the critical value. And this is where I was saying I was off a little bit. 569.8. So I had B, and I think that was the answer key what they had. And then when I changed this to the inverse norm they gave us, like from the normal distribution table, I was seeing, will that give me the answer on the key? I still didn't get it. I couldn't remember. So if we had 2.57, that rounds to like 2.58, but even if I did 2.57, okay, let's try it. So this was 220 when I divided. 220 times, let's go 2.57. 220 times 2.58. So the differences are just from your, the rounding, T star versus Z star, and they're just negligible. And obviously the closest one is this one right here. So when I did my T star value, I got, let me do it again. I'm sorry. 220 times, I used 2.59. And I got 569.8. But that was the closest we got. So, and again, that was just the difference between using T star, Z star, and some rounding issues. But this is the closest one. And the answer. Let's just see. Okay. Oh, sorry. I want to also say this. Never stop talking. Is you could do the lower and the upper bound by just subtracting. I rounded this up to 570. The lower and the upper bound would come from subtracting 570 from this and adding 570. So 73 to 20 minus 570. And don't get too caught up with these numbers don't exactly match that, right? It's an interval. 73 to 20 plus 570. 73,790. We can say with 90% confidence that the true mean of full-time professor's salary, the mean of full-time professor's salary is captured by 72,650, 73,790.